To talk about and walk through how to compare two different groups and do a comparison of means to identify an average treatment effect, I want to walk through an example of whether or not politicians racially discriminate in the acquisition of government services. So, another way of asking this is, do legislators discriminate against individual requests for constituency service based on race of the individual who is asking a service? This is a pretty common survey, and it's been conducted a number of different times using different types of government services. Now, there are different ways that we can think about setting up our hypothesis test. Yes, that's exactly what we're going to be doing, as well as other things like whether or not that respondent is affiliated with a party or whether they're a Republican or a Democrat, that would impact the likelihood that a white constituent would reach out to that politician. So in our example, we're going to design our experiment so that we are contacting different state legislators in 44 different state legislatures with any of them that had a valid email in September of 2008. What the experimenter did was they signaled not only the race randomly in the email, it was also sent from an account with that same name. The two names that they were randomizing that signaled race were Jake Mueller and Deshaun Jackson. We can talk about whether or not that is correct, and actually there's some pretty interesting methodological work that verifies that these names are associated with race, at least with regard to how the legislators themselves are receiving it, which is an interesting way of measuring how legislators are conceptualizing their own constituents. The text of the email was also manipulated so as to signal the partisan preference of the email sender. So we're going to have a cross tabulation between the race and the partisan preference of the person sending the email, which is going to result in 6 different treatment categories. The outcome variable then, or the response, is going to be whether or not the legislator gave any sort of email response or via mail. When we then look at the difference between the means, we can see that we're going to get some difference between the two, which is going to be approximately 4 if you go up and down the no partisan signal. And we're then also going to have some sort of p-value that's associated with that estimated coefficient. Now, how are we going to go about doing that? You might have guessed it, mostly because I said it, but we're going to run a hypothesis test. So let's begin just by creating some fake data that is pretty much identical to the information that was found in the previous table, and we'll load that into R. So we have our 2 independent samples. One is the group that had the name Deshaun, the other is the one with the name Jake. And here what I'm doing is I'm creating my own function that's going to conduct a t-test. All we're doing here is we have 2 groups, so that's what input vec1 and input vec2 is, and then we have our null hypothesis. In this case, we're going to conduct a null hypothesis to see whether or not these 2 groups are equal. So if our alternate, or what we're interested in, is whether or not they are not equal, then we set up our null such that the groups are equal. Now, all we're doing in line 5 is taking the mean from both of these groups. I'm then taking the standard deviation from these groups, getting the number of observations, and then I can calculate the standard error. Don't forget that we have to tell the function how many degrees of freedom there are. This is going to be self-contained, so you don't have to worry about it, but it lists the parameters that are necessary in order to calculate that, and then we end up getting some sort of t statistic. Once we have our t statistic, you'll remember that we need to make some sort of inference from that. We use our p-value, which is going to be a measure of surprise. That's what's happening in line 18. Because this is a 2-sided test, we are multiplying that by 2. And then this is going to return not only the difference in means, it's going to tell us what the standard error, the test statistic, and associated p-value is. Now you can do all of this in R, but I want to show you exactly what's happening in the background if you do that. We can now test out our little by hand function, put in our 2 input vectors, and again, it's going to give us that difference of mean. It's giving us our standard error. We have a very large t statistic, and because of that, we have a very small associated p-value. Now, again, like I said, there is a function in R that does this already, and all we have to do is tell that it doesn't have equal variance. And again, that's because we have 2 independent samples. Then we get basically the exact same results, right? We can see that our t statistic is sufficiently large and our p-value is basically 0, which means that we do have sufficient evidence to reject the null hypothesis that the 2 groups are equal, meaning there's probably sufficient evidence that they are not equal. But we can't make that type of statement because of the way we are constructing our null hypothesis.